Japan is located at the intersection of four massive tectonic plates: the Pacific Plate, the Philippine Sea Plate, the North American Plate, and the Eurasian Plate. Because of this, Japan is one of the most earthquake prone countries in the world. And yet, even when earthquakes reaching seismic intensity level 7 occur, complete collapse of urban functions is surprisingly rare. In fact, in the earthquake that struck off the eastern coast of Aomori on December 8th, a magnitude 7.5 quake and a maximum seismic intensity of upper 6 were recorded. Even so, no deaths were reported, and only 2 serious injuries occurred, with most cases being minor injuries. Even in residential areas and public facilities, serious damage such as building collapse or destruction of major infrastructure was rarely observed. Every time earthquake footage from Japan is broadcast overseas, foreign media repeatedly ask the same question: how can cities continue to function after such intense shaking? In many other countries, earthquakes of similar scale often lead directly to building collapses and infrastructure failures, resulting in large numbers of casualties. So, why is Japan able to limit damage to this extent? The answer is not luck or coincidence, but a structure created through policy and engineering design. How disasters shaped Japan's building standards. Japan's seismic standards were not always this strict. A major turning point was the Great Hanshin earthquake in 1995. During that disaster, many buildings collapsed, revealing that existing standards were insufficient. As a result, Japan's Building Standards Act was significantly revised, introducing new seismic regulations designed to prevent collapse. Later, the Great East Japan earthquake in 2011 exposed not only the dangers of shaking, but also the vulnerability of infrastructure and tsunami preparedness, leading to large-scale revisions of urban planning and disaster prevention systems. In Japan, every major disaster has led to updates in laws and standards. Today's earthquake resistant technology is the result of decades of learning through painful experience and loss. What makes Japan's seismic technology different? Buildings in Japan generally use three types of structural systems. The first is earthquake resistant structures, which strengthen columns and beams so that the building itself can withstand shaking. The second is vibration control structures, which use devices such as dampers inside the building to absorb seismic energy and reduce deformation and damage. The third is base isolation structures, which place rubber bearings or sliding devices between the building and the ground, preventing ground motion from being transmitted directly to the structure. In high-rise buildings, even more advanced systems are used, including massive counterweights that move in the opposite direction of shaking and real-time vibration control technologies. What makes Japan unique is that these technologies are not limited to landmark skyscrapers. They are widely used in apartment buildings, hospitals, and commercial facilities as well. In many countries, seismic design often only aims to meet minimum safety requirements, simply ensuring that buildings do not collapse. In Japan, however, many structures are designed not only to remain standing, but to remain usable even after major earthquakes. In other words, Japanese seismic engineering is designed not just for survival, but for keeping society functioning. Why damage cannot be reduced to zero. Japan possesses some of the world's most advanced seismic technology. Even so, damage cannot be completely eliminated. This is not because of technological limitations, but because of how fast society can realistically upgrade its buildings. Some homes and structures were built before current standards were introduced. Upgrading them to meet modern seismic codes can cost several million yen or even tens of millions of yen in some cases. For individual homeowners, this is a heavy financial burden, and in rural areas especially, retrofitting progresses slowly. The problem is not that Japan cannot build safe structures, but that it cannot replace all old structures quickly enough. Japan's earthquake risk today is therefore less about engineering and more about economics and social systems. The greatest danger is not shaking, but tsunamis. Among foreign visitors to Japan, some may believe that they must immediately run outside when an earthquake occurs. However, in reality, the leading cause of earthquake related fatalities in Japan has not been the shaking itself, but tsunamis. Japan's newly constructed residential buildings, as well as hotels, convenience stores, shopping malls, train stations, and airports, are all legally required to meet the country's current seismic safety standards. In Japan, buildings that carry a higher risk of collapse during earthquakes are older private residences built before the 1980s, prior to the introduction of stricter seismic regulations. Buildings used by the general public, such as hotels, ryokan, and commercial facilities, must undergo seismic retrofitting to meet national standards, even if they are old, in order to continue operating. As a result, there is very little need for tourists to worry about building collapse in the facilities they use. Therefore, as long as you are inside such buildings, even during strong shaking, the likelihood of the structure itself collapsing is extremely low, and rushing outside may actually be more dangerous due to falling objects. In other words, remaining inside a seismically designed building and being located several hundred meters or more away from the coastline. If these two conditions are met, the risk of losing one's life due to an earthquake can be considered extremely low. On the other hand, when staying in coastal tourist areas, port districts, or low-lying regions, it is crucial to confirm evacuation routes to higher ground in advance. This is because in coastal areas, responding to tsunamis, rather than the shaking itself, far more often determines survival, which is why evacuation routes and signage are thoroughly maintained. In short, in Japan, rather than simply running away when the ground shakes, it is far more important to take the correct action based on your location. Conclusion: Japan's earthquake resistant technology is highly regarded worldwide, not simply because of engineering expertise. It is the result of social decisions, learning from disasters, revising laws, and updating standards over time. Safety did not emerge by chance, but through long-term investment and deliberate policy choices. And even now, those systems must continue to be maintained and updated. Japan's seismic resilience is the product of a society that has continuously learned from past disasters and continues to redesign itself for the future. Thanks for watching. Subscribe to Deep Focus Japan for more videos on Japanese society and current issues.